Today we'll look at adding polynomials together. In order to add polynomials, we combine like terms. Like terms have to have the same variable and the same exponent. Typically, I like to start with the biggest exponent first and see if we have any that have the same exponent. So my biggest exponent's x to the fourth. So I look, I don't see any other terms that have x to the fourth. So I have one x to the fourth. I would then look for x to the third. I see a negative 4x to the third, negative 4x to the third, and no more other x to the thirds, so I have nothing to combine that with. Then we have a 7x squared and a 3x squared. Those are like terms. We can combine those together. 7x squared plus 3x squared, 7 plus 3 is 10, x squared. Then we also have a negative 8x and a 2x. Those are considered like terms because they have the same variable, the same exponent of 1. And negative 8 plus 2 is negative 6x. When we subtract exponents, we still technically combine like terms, but we first need to distribute this negative into this set of parentheses. Some people might call that keep, change, change. So what that would look like, we're going to change the plus the minus sign. We're going to change the minus sign to a plus sign. The 8 becomes negative, the 6 becomes negative, and the 5 becomes positive. At this point, we would combine our like terms. I see a 3x to the third and a negative 8x to the third. That equals negative 5x to the third. We have a negative 7x and a negative 6x. We combine those, we get negative 13x. And then we have a 5 and a 2. 5 and 2 added together is 7. We have subtracted the polynomial by distributing the negative and combining like terms. We're now going to multiply polynomials, and in order to multiply polynomials, we're going to use a box method, or we can talk about doing it other ways, but these notes are for doing a box. We're going to draw a box. The height of the box should be 1 more than the degree of the first polynomial. So if the degree of the first polynomial is 2, we should have 3 boxes. The length of the box should be 1 more than the degree of the second polynomial. So if the degree of the second polynomial is 3, we should have 4 rows. We're going to write the polynomial that we're multiplying on the outside edges of the box. And then we're going to multiply to get each box's value on the inside. Like terms can be found on the diagonals, and we're going to combine those. And then we're going to write our answer in standard form, from biggest exponent to smallest exponent. Let's look at a few examples. We have 4x minus 3 times 2x plus 7. So 4x and negative 3 would go here. 2x and 7 would go there. Or you can switch those. That does not matter. Then we simply multiply to get the numbers inside the box. 4x times 2x is 8x squared. 4x times 7 is 28x. Negative 3 times 2x is negative 6x. And negative 3 times 7 is negative 21. The like terms can be found on this backside diagonal here, and we would combine those together. So for our final answer, once we multiply, we get 8x squared. 28 and negative 6 is negative 22x minus 21. Let's try this example. 2x minus 1 quantity squared. What does that really mean? That really means 2x minus 1 times 2x minus 1. We multiply that using the box, we get 2x minus 1 and 2x minus 1. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is negative 2x. And negative 1 times negative 1 is positive 1. We would then combine our like terms on the backside diagonal. We get 4x squared. Negative 2x and negative 2x is negative 4x plus 1. Can we do this with more than a binomial, maybe a trinomial times a binomial in this case? X squared, 3x, and negative 5. On top, we would have 2x and negative 8. We multiply all the boxes together. X squared times 2x is 2x to the third. X squared times negative 8 is negative 8x squared. 3x times 2x is 6x squared. 3x times negative 8 is negative 24x. Negative 5 times 2x is negative 10x. And negative 5 times negative 8 is 40. As you'll see, the like terms are on these backside diagonals. So we have 2x to the third. Negative 8 and 6 would be negative 2x squared. Negative 24 and negative 10 would be negative 34x. And we have this plus 40 as well. We can switch the order. We can put the binomial on the left and the trinomial on the top. So we get 10x minus 1, negative 2x squared, plus 1x minus 5. 10x times negative 2x squared is negative 20x to the third. 10x times x is 10x squared. 10x times negative 5 is negative 50x. Negative 1 times negative 2x squared is 2x squared. Negative 1 times x is negative 1x, and negative 1 times negative 5 is positive 5. Combine our like terms, again, those would be on the backside diagonals. We see that we get negative 20x to the third. 10x squared and 2x squared is 12x squared. Negative 50 and negative 1 is negative 51x plus 5.